Welcome. In this lecture, we build on the last two lectures to give kind of a fancy notation. It's very useful to have kind of a more general way to symbolically represent something so that you can do things with it, as we're going to want to do with these by taking limits. So bear with me with the notation. You can do it. So let's get started. So when we have the first thing that we have, so let's say we're dividing. So we're dividing the interval AB. So dividing the interval AB, and we're dividing it into n subintervals. So into n subintervals. So into n subintervals. Right. And the first thing that we remember, right, well, let's actually start drawing the picture already over here. So I have, this is like my x-axis, right? And I have here my A and I have here my B. And I said I wanted to divide this into n subintervals. And so how do I do that? I take the entire width, which is B minus A, I divide it into n subintervals. So I have to divide it into n pieces. Okay, so and remember that we call the width of each piece delta x. So let's go ahead and do that. So I write, so we're dividing this. So the first thing that we get is that delta x is going to equal, right, the width of the top interval. So we get b minus a, and then we divide that by the number of subintervals we want. And then we can use that to figure out what each of the endpoints of these intervals is. So we get that xi, right, so this, I used, okay, we're going to call them xj, and this is going to equal, remember what we do is we start with that a, and then we add the number of times, right, we add j, this j, times the width, right, because we have to move over, we start at a, and if I'm talking about the n, like xj, here, let's write this on here, so we kind of did before. This is a, so this is x0, right? And then the next one was x1, and then we got x2, and we kept on going, and this would be like xj. But remember that the like x1 talks about the first subinterval, right? And if I want left endpoints, I'm looking at here. And for the second subinterval, right, I've got to move over, to get to x1, I had to move over one copy of delta x. To get to x2, I had to move over two copies of delta x. To get to x3, I will move over 1, 2, 3 copies of delta x. To get to xj, I have to move over j copies of delta x. So that's where that comes from, okay? And then we remembered that this one here, so another tricky thing to remember is that this is going to be xn, right? Okay, so we figured out this much. And then if I want to know the ith interval, so if I wanted to know the first interval, it's the interval that starts at 0 and goes to 1. The second interval starts at 1 and goes to 2, and so on. So I'm going to write down the funny notation for this. Ready? So what we're going to do is that I'm going to get xj minus 1 to xj, right, is a jth interval. Right? And let's test this. Okay, so looking at this, what's the first interval? So the first interval is going to be x0, x1, right? So we're testing this, so let's test. To kind of get comfortable with the formula. So the first interval, right? Well, it's x0, x1, right? That looks right, okay? Because 0 is, right, first interval, so my j equals 1, and I subtract off 1, I get this, I keep it, and I get that, right? And then to do the second interval, Okay, so I know that right, so if I'm looking at the second interval, then my left endpoint is my right endpoint is x2, my left one is x1. So I have x1, x2. So this index really does match up with this. This is kind of a little sloppy of me there. Okay, so this endpoint, this right-hand endpoint, really does match up with this. For my left-hand endpoint, I needed to subtract one. Okay, so we kind of believe this at this point. So now let's kind of keep going here. So I have the graph of my curve. So y equals f of x. Boom, 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 boom. Right? And then I have, and then I do, to do these rectangles, I go, right, I'm doing left hand, so I go like this, like this. I'm going to do left hand, I'm going to have one here. And I'm going to have, the one there is a little harder to, right, it goes like this. Okay. And that's xj minus 1, xn minus 1. This is xn minus 1. Okay. Now each of these, so this is area 1. This is area 2. We keep going. So I took it from this side. So actually, the easier one to do here is like this. Okay. Okay, so from here, this is AJ. So that's actually AJ plus 1. Right. And then this one is actually, right, so it comes from the side, so this is actually AN, my last one. Which is good because I should have n areas and I started at 1. Okay, perfect. So if I wanted to get this left-hand sum, right, that tells me the sum of the area of these rectangles, then what do I want to do? I just want to add those areas together. So I want to take that this is equal to, well, I'm just going to get, so this is equal to, so I have A1 plus A2 plus all the way up to AJ plus all the way up to AN, okay? And then we remember, right, I know that I've used n there, but we're going to use this also. This is like my delta x. And then we have this point here, right? This is going to be, the point here is going to be, well, here it's going to be x0. And then it's going to be f of x0, which tells me that this height here is f of x0. Okay. And then maybe it's easiest, instead of crowding that one, to look at what's happening here. So I still have that this is delta x. And then here I have, so this is xj minus 1. So that's actually going to tell me that this height here, right, is going to be f of xj, right, because it's the y coordinate of that point there. Okay, and then I could keep on going and notice that this height here is going to be f of xn minus 1, and this width here is delta x. Okay, so let's do the next step of this. Each of these has a delta x, and then it has the height. So I have, this is going to equal. So I have delta x times, and then my first one is f of x0 plus, and then I have, I replaced my green with another coming green apparently. So then I have delta x times f of x1. I'm going to keep going. And I have delta x times f of, and then we here, for the jth interval, I actually have xj minus 1, right? And then we keep going, and I get delta x, and then I have f of xn minus 1. Okay, and we notice that when we're doing this, right, this is this n here. I'm double using red because I only have so many colors. Okay, so there is a way to kind of write this in sigma notation. So let me show you. So this is going to equal the sum from, right, and we start with, so our j here, we're going to start with 1 because we're going to start with the first interval. So we're going to have to subtract off 1 to get that, right? And then we're going to end with n. And I have this f I'm going to put the inside of that in orange. So this is x, so that you can very well see what's on the inside. In fact, why don't I do that for each of these? This is x0, this is x1, because I think the green's a little hard to see, but the orange is really nice and crisp, and these are also a little tricky to work with. And this is x and minus 1. Okay, so here we go. So this is x j minus 1, and then this is delta x. Okay, and we can just kind of pull out the delta x if we want, and we're going to get, so then we have delta x times the sum, and we're going from j equals 1 up to that special n, and then we're taking this of f of x j minus 1. Okay? Let's make sure that's really clear because that's really important. So that's xj minus 1. Okay. And this has a special name. So both of these, either of these, has the same special name. And the special name for either of those is sigma notation. So sigma notation. And one of the things that can really help, if you're getting a little confused by summation notation, is to write out a few of the terms, kind of like we have here, and align those in a particular circumstance and see if you kind of believe and understand how it works. I understand sigma notation takes a while to get used to. It's a little tricky. It's notation. But one of the things that happens that's really useful when you use notation is that then you can do things like take limits and like work in more complicated circumstances. Okay? I'm going to do the same thing with orange here before we finish off. So this is x0. This is xj. And this is x, in case you couldn't read it very well, xn minus 1. Okay. Great. So I hope that made some sense. And I will see you in the next lecture.